Good afternoon, dear learners. You are welcome back in this lecture also. First of all, I thanks to Honorable Principal of our college, Dr. Dhananjay Chate, sir, to inspire me to have an online coaching. Sanjeevanee Mahavidyalaya Chapoli is affiliated to Swami Ramanand Tirth Marathwada University, Nanded. Now we discuss again same unit number 1 from paper number 9, Semiconductor devices. Remaining part we discuss. In last lecture we have seen about intrinsic semiconductors. Now we discuss about extrinsic semiconductors in detail. We have seen intrinsic semiconductors and extrinsic semiconductors. Now we discuss. Intrinsic semiconductors are pure and extrinsic semiconductors are what? Impurities added in it. But there are two types of impurities, pentavalent and trivalent. If pentavalent impurities are doped in pure form, then semiconductor so formed is said to be n-type. And if trivalent impurities are added to the pure form of the semiconductor, then the formation of p-type of extrinsic semiconductor will be there. This already we have seen. Now let's turn towards the concept of extrinsic only. Actually, there are two extrinsic types semiconductors, p-type and n-type semiconductor. There are types of dopants in extrinsic semiconductor. Crystals of silicon and germanium are doped using two types of dopants. What are those? Pentavalent, in the sense having valency 5, like arsenic, antimony, phosphorus, etc. Trivalent impurity, it means it has valency 3, like indium, boron, aluminum, and so on. Here it is given, the reason behind using these dopants is to have similarly sized atoms as the pure semiconductor. It means doping is to be done. In what way? There should not be change in the crystal structure. Both silicon and germanium belongs to fourth group in the modern periodic table. Hence, the choice of dopants is from the third and fifth group. This ensures that the size of the atoms is not much different from the fourth group. Hence, the trivalent and pentavalent choices, these dopants give rise to two different types of semiconductors. What are those? N-type, P-type. So two types, N-type and P-type. What is meant by N-type semiconductor? First of all, we see. An N-type semiconductor is created when pure semiconductors like silicon and germanium are doped with pentavalent elements. As can be seen in the image above, when a pentavalent atoms takes the place of silicon atom, 4 of its electrons bond with 4 neighboring silicon atoms. Here you see. Got it? Then, however, the fifth electron remains loosely bound to the parent atom. Hence, the ionization energy required to set this electron free is very small. Thereby this electron can move in the lattice even at room temperature. You see here, under free electron, unbonded free electron donated by pentavalent. 1, 2, 3, 4, and this one is what? Fifth one, pentavalent impurity. Here one extra electron is there, free electron is there. From this figure it is clear. When a semiconductor is doped with a pentavalent atom, electrons are the majority charge carriers. Already I have shown you in figure. Majority carriers is what here? Electron. Pentavalent electrons are the majority carriers. On the other hand, the holes are the minority charge carriers. Therefore, such extrinsic semiconductors are called as N type of semiconductors. In an N type semiconductor, number of free electrons is more than the number of holes. Ne is greater than Nh. And in case of P type, what happens? Nh, the number of holes, is more than the number of free electrons. Because of what? Trivalent. How it happens, I will show you in figure. A P-type semiconductor is created when trivalent elements are used to dope pure semiconductors like silicon and germanium. As can be seen in the image above, when the trivalent atoms takes the place of silicon atom, 3 of the electrons bound with the 3 neighboring silicon atoms. 3 of them bound with the 3 neighboring silicon atoms. Then what happens? Yes, here 3 of its electrons bound with the 3 of neighboring silicon atoms. However, there is no electron to bond with the 4th silicon atom. I mean, there is no electron, there is a deficiency of electron to bond with the 4th silicon atom. This leads to a hole or a vacancy between trivalent and the 4th silicon atom. This hole initiates a jump of an electron from the outer orbit of the atom in the neighborhood to fill the vacancy. This creates a hole at the site from where the electron jumps. In simple way, or in simple language, in simple words, we can say that a hole is now available for conduction. When a semiconductor is doped with a trivalent atom, holes are the majority charge carriers. On the other hand, the free electrons are the minority charge carriers. Therefore, such extrinsic semiconductors are called as what? P type of semiconductors. So already I have told you, in N type semiconductor, number of electrons is more than the number of holes, but in P type, number of holes is greater than the number of electrons. Holes are the majority carriers. So in this way, extrinsic semiconductors are of 2 types, N type and P type. Here in figure also it is shown. I will show you figure. Here you see what happens when trivalent added, when pentavalent added. So depending upon the impurity which we add in the pure form of the semiconductor, that is silicon and germanium, they are classified into again what? P type and N type. Remember, in P type of material, holes are the majority carriers, whereas in N type of semiconductor, electrons are the majority carriers. When such a material, that is P type semiconductor and N type semiconductor, when they combine to form a junction and two electrodes are connected to it, so we obtain a passive component called as p-n junction diode. P-n junction diode, and this is our semiconductor p-n junction diode. So there are two electrodes, one is anode, other one is cathode. Got it? So in this way, the semiconductor diode is a two electrode passive component. It is useful for a rectification purpose. I mean, that is to convert alternating current to direct current. So sometimes this semiconductor diode is also called as what? A rectifier. As you know, rectifier is nothing but a device to convert AC into DC. That process is said to be a rectification. I mean, it is a very important component in our electronics industry for the rectification purpose, because easily we can obtain DC from AC. So it is one of the peculiar property, a very important property of the semiconductor diode is that of what? A rectification. It has the property of rectification, so it is said to be rectifier also. And one more point, remember, this diode conducts in case of only forward biasing. Again you may ask, what is meant by biasing? What is meant by forward biasing? There is one more biasing, that is reverse biasing. In reverse biasing, diode will not conduct. It means it looks like an open switch in reverse biasing. Then you may ask a question, what is meant by biasing? Sir, you are telling about biasing. It conducts in forward biasing. What it doesn't conduct in reverse biasing. And what is meant by biasing? What is forward and what is reverse? This question you may ask. So remember, boys and girls, forward biasing means what? Biasing means simply potential difference is provided to the respective terminals of the diode. If positive terminal of the diode, I mean anode of the diode is connected to the positive terminal of the power supply battery, and if negative terminal is connected, negative terminal of the diode, that is cathode, is connected to negative terminal of the battery, and potential difference is provided, then such a potential difference which we have provided, that is positive to anode and negative electrode of the battery is connected to cathode of the diode, such a biasing is said to be forward biasing. And if positive terminal of the battery is connected to negative terminal of the semiconductor diode, I mean for positive terminal of the battery is connected to negative terminal of the diode, and negative terminal of the battery is connected to the anode of the diode, and potential difference is provided, such a biasing is said to be reverse biasing. But remember forever that diode conducts in only forward biasing. It doesn't conduct in reverse biasing. In reverse biasing, it acts like an open switch. In short, we say in forward biasing, it converts AC into DC. It is useful in rectification, but in reverse biasing, it doesn't conduct. So it acts as an open switch. So in this way, we have discussed about simple semiconductor diode in details. Remaining matter Later on we see.